started on this one, there's a lot going on. One of the things that you might be tempted to do in this particular one is divide everything by -2, okay? And I want you to know that that is a reasonable thing to do for part 5, okay? It's a very reasonable thing to do. It makes it much nicer, much prettier, and it absolutely makes it easier to solve once we get to the solutions. However, if you divide everything by -2 at this point, you're going to end up with a different vertex. You will end up with the same x-intercepts, but your vertex will be different. So don't factor out a -2 out of all 3 terms, okay? But we are going to deal with that -2. So we are going to deal with that -2. So we are going to have f of x equals, and we are going to take the -2 out of the first 2 terms. Okay, so I have -2 times x squared plus 10x. And what I have done is I move that -42 out to the side. Okay, I move that -42 out to the side. Okay. Now, I'm going to complete the square. What is half of 10? 5. And what's 5 squared? Good. This is where students make mistakes. This step right here. We aren't actually adding 25. We are adding 25 times -2. What is 25 times -2? -50, okay? And here I had the comment, we're not adding 25, we're actually subtracting 50, and that's exactly right. So on this portion, we are adding -50 or subtracting 50. Now, once I move to the outside of my parentheses, I have to do the opposite of that because we are dealing with the same side of the equation. Okay, I'm not dealing with opposite sides. I'm dealing with one side. And so if I add -50, what do I have to do with the -42? Plus 50, okay? That right there is where students make mistakes. That right there, doing the opposite. Okay? Now we factor. Yes, question?
It went to plus 50 because of the -2 on the outside.
Correct. So 25 times -2 is -50, and we do the opposite. Good. So then I get x plus 5 squared plus 8. Okay? So that right there is the first part of this problem. This is number 1. It is my vertex form. Now, from my vertex form, can I identify my vertex? What's my vertex? -5, 8. Okay? From that, can I identify my axis of symmetry? What's my axis of symmetry? X equals, yes, the x value in your vertex. Okay, so your axis of symmetry is x equals -5. Okay, can I identify my y-intercept? What's my y-intercept? Yes, very good, -42. And so it would be 0, -42. Now I'm at my solution step. When I get to my solution step, I'm going to go back to the original problem. I'm going back to the original problem, and I set it equal to 0. Now, factoring out a -2 makes this problem significantly more manageable when you factor. So I'm going to factor out a -2. Is that plus 21? Yes. Okay. squared plus 10x plus 21, that can be factored. Okay? It's kind of a nice little factoring thing. So that's x plus 3 and x plus 7. Okay? So my solutions then I have x equals -3 and x equals -7. Okay? Those are my solutions. So I've done 1, 2, 3, 4, and 5. What's my last thing I've got to do? Sketch it. Okay? I still see people writing, so I'm going to pause just for a second while people finish writing that. Yes, ma'am? Review notes. Yeah. I just want you to practice some problems and then see me do them. We good? I think I got everybody. Okay. Now we are going to sketch this. Now, if you noticed, what is my y-intercept? -42. So if we're looking at this x and y axis up here, we're talking like at the floor, -42. So I did try to make sure on your test it wasn't, that it was easier to graph. Now, my x-intercepts, what were my x-intercepts? -3 and -7. Okay. And then I've got to go up to +8, right? For my vertex. So I need to draw some higher things. Okay, here we go. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7. Okay. What's my vertex? Okay. So there's my vertex. And then my solutions were -3 and -7. Okay? So in this particular graph, we have a y-intercept, but we really can't graph it because it's so far down. Okay? And I'm looking for a sketch. I'm not looking for anything to be perfect. I'm looking for your x-intercepts, the shape of the graph. In this, I'm looking for the quadratic. And if it's possible, your y-intercept. Okay? Yes, ma'am? And the y-intercept if you're able, yes. You got it. Good job. Okay. Now, we have another sketch, and I'm going to give you about 3 minutes to do the next one, okay? Actually, I think I'm going to give you 5 because I forgot I added a lot to it. Okay? So here, I'll give you 5 minutes to do this one. You are describing the end behavior of this, the end behavior. You're identifying the y-intercept, the solutions, real solutions, complex solutions, linear factors, and the sketch. Okay? So I'm going to give you 5 minutes to do that. look at this one. Okay? The first thing we are asked to do is describe the end behavior. So there's two things that go along with end behavior. It's do they both go up, both go down, or do they go in opposite directions? This one goes in opposite directions. How did you know that?
Honestly, I plugged it in.
Okay, you know, I appreciate that. Honestly, I plugged it in my calculator. Good. How else can we know? Because the exponent's odd. Okay? So this exponent being odd means it's going to go in opposite direction. Now we look at the leading coefficient. That's the number in front of the x to the fifth. Is that positive or is that negative? It's positive. So we are going to have something that looks like a positive slope of a line. That's what the end behavior looks like. It starts in the bottom left and goes to the top right. A picture is completely fine for describe end behavior. Okay? Now, what is my y-intercept here? 0. Okay? It's 0, 0. Now, if my y-intercept is 0, 0, what is one of the solutions? X equals 0. That is one of the solutions. Good. Okay, now we're going to focus on number 3 right now. Number 3. Okay, I need solutions to this. So I have 0 equals x to the fifth minus x. The first thing I can do is I can factor out an x. And I'm left with x to the fourth minus 1. X times x to the fourth minus 1. Okay? X to the fourth is a perfect square that sometimes we don't realize is a perfect square. What is the square root of x to the fourth? X squared. Okay? So this becomes x times x squared plus 1 and x squared minus 1. Okay? Now, this can be factored further. Okay? That is a difference of perfect squares again. So I have x times x squared plus 1 times x plus 1, x minus 1. Okay? Now I can start solving for some of these. I have x equals 0, and that's going to give me a solution of x equals 0. Yes, sir? How would you factor it? No, I'm asking, what would you do? X plus 1 times x plus 1? Okay, x plus 1 times x plus 1. X times 1, if you FOIL x plus 1 times x plus 1, you get a middle term. You get x squared plus 2x plus 1. Yeah. A lot of students, that's a very common thing for students to think, but it has to be a difference. You have to have a subtraction sign to factor it further. Good question. Yes, sir? If you plug in 0 for both of those x's, you're going to get x to the fifth, or 0 to the fifth minus 0. And so you plug 0 in for x is how you find the y-intercept. That's a great question. Thank you. Okay? So I get x equals 0. Then I get x plus 1 equals 0, and x minus 1 equals 0. So I've got 3 solutions. And these are all real solutions, and they are all where I cross the x-axis. I cross the x-axis at all those points. Now I want to go up and I want to deal with this x squared plus 1. So I'm going to do x squared plus 1 equals 0. I solve for x. I get x squared equals negative 1. When I take the square root of both sides, what do I have to put in front of that square root of negative 1? Good. Don't forget that plus or minus. So I end up with x equals plus or minus the square root of negative 1. What is the square root of negative 1? I. So I end up with plus or minus the square root of I. I actually have 5 solutions here. My solutions are 0, -1, +1, I, and -I. I have 5 solutions. Is that in keeping with the number of the highest exponent that I have?
Yes.
It does. Okay. Now, some of those are real and some of those are complex. Which are real? Meaning they cross the x-axis. Which are real? The first 3. 0, -1, and 1. Those are real. What's my complex or imaginary? It's I and -I. I and -I. Okay, and what were you asking?
No, I was just answering the second.
Okay. Now, my linear factors, I've already got some of those linear factors. That's a linear factor because it's to the first power. X plus 1 and x minus 1 are linear factors because they're all to the first power. X squared plus 1 is not linear. Okay, x squared is a quadratic and it is not linear. So, for number 6, for part 6, okay, I have some of my linear factors. I have x, and then I have x plus 1, and I have x minus 1. Now, linear means my x has to be raised to the first power. So if I have I as a solution, what is the linear factor associated with I? Excellent, x minus I. Then if I have -I as a solution, what's the factor associated with that? Okay? So students typically do okay with the solutions, and sometimes they get confused between the real and the complex. So I wanted to really identify that clearly, the difference between the real and the complex.
I'm still a little bit confused on how we know that, like, that x out in front is x equals 0.
Well, because we're setting every single factor equal to 0. Okay? And so that is one of our factors. Okay? So that property allows us to do that. And you could think of it, if you wanted to, you could think of x as x plus 0. Okay? And a lot of times that's helpful because, so it's just x plus 0. We just don't write the 0 down. So, but if you need to write that 0 down, you can. It's still correct. That was a good question. Thank you. Okay, let's sketch this thing. Can I move? Okay, here we go. What are my x-intercepts? My x-intercepts. Good. -1, 0, and 1. What's my y-intercepts? 0. Okay. All we know, that's all we know. Okay? That's all we know. If you plug this into Desmos or a graphing calculator, you're going to see something kind of like that. But we can't, that little loop over there, we can't know that because we're graphing. That's the complex. This is the behavior of your complex solutions right here. Okay? Okay? Yeah, it's because of your range. Like if you'd have to zoom out quite a bit. Yes?
So would we have to sketch the complex?
You would not sketch the complex on your tests. You would not sketch the complex. I'm looking for y-intercept, x-intercept, and direction. Okay? Okay. Now, for the next one, let me see how much time we have. Oh, we're good on time. Okay, I'm going to give you 5 minutes to do these. Now, the other class was like, what are we doing? So, you are dividing. You don't have to find zeros. All you have to do is divide. I would use synthetic division. Okay? For this one, you're simplifying. But what you're going to have to do here is you're going to have to rationalize the denominator. Rationalize the denominator. That's what you're doing for that one. Let's get started on this. I know that you might not be able to finish all of it in the time. I just want you guys to start working on it, see what you can do, and then watch me do it. Now, the thing that I want you to be aware of here, this right here is your factor. That's your factor. We have to get the solution that's associated with that factor, okay? And the solution that's associated with that factor is 8, okay? Then we look at the coefficients. I have 2, negative 17, 11, and negative 24. Okay, so I just write those down. In order to do synthetic division, I'm going to bring my 2 down. Okay, 8 times 2 is 16. Negative 17 plus 16 is negative 1. 8 times negative 1 is negative 8. 8 times 3 is 24. And I accidentally gave you one without a denominator, or without a remainder. I meant to give you one with a remainder so you could practice that. Okay? So, if I'm rewriting this as your answer, it's going to be 2x squared minus x plus 3. Let's pretend there was a remainder. Let's pretend there was a remainder. What would I put that over? Yes, x minus 8. And what would I have to have in between the 3 and the fraction? A plus sign, okay? I had a couple people email me from WebAssign, and they didn't have that plus sign in there. So don't forget you've got that plus sign. Okay? Now, for -1 plus 4i over 8 plus 2i, you have to rationalize the denominator. Rationalize the denominator. And to do that, you have to multiply by the conjugate of the denominator. The conjugate of the denominator. What is the conjugate of 8 plus 2i? Excellent, 8 minus 2i. And if I multiply the bottom times 8 minus 2i, what do I have to do to the top? Same thing. It is not the same, but that is a way that some people would think about it, yes. But it's not exactly the same. Okay? Now, I've got to FOIL the top and I've got to FOIL the bottom. My I is not going to disappear from the top. Okay? It's not going to disappear from the top, and that's okay. Okay? I have -1 times 8, -1 times -2i. Okay? 4i times 8 is 32i. 4i times -2i. That gives me -8i squared. Okay, I times I is I squared, and what's I squared? Excellent. 8 times 8 is 64. 8 times -2i is -16i. 2i times 8 is positive 16i. 2i times -2i, that is minus 4i squared. That I is squared. Now, I can combine like terms. Okay? What is I squared? -1. So I'm changing that. I'm simplifying this sum.
Those 16 I's cancel.
Yes, which is exactly what we want to happen because we're cleaning up the bottom. And then what happens to the I squared? What does it become? Excellent. Okay, so I have -8 plus 34i plus 8. Then in the denominator, I have 64 plus 4. Okay? So I end up with 34i over 68. What goes into 34 and 68? 34. Good. 34 does. So what does this simplify to? 1/2 I. Some students write that I over 2, and that's completely fine. I over 2 is completely fine. Okay? Can I go to the next screen? I'm going to give you about 3 minutes to do this one. I don't want you to make this one harder than it is. Okay? And that is the reason that I like to show this one. Do not make it harder than it is. Okay? You can factor this one pretty straightforward. Okay? you know I have another set of twins and I didn't know it? Yeah. Hannah and Megan Glover. Yeah, they're in different classes though. And I said, I have a student in another class that has your same last name. And she goes, yeah, it's my twin sister. I should have put that together.
I have, Megan.
Oh, it's you then. Okay. Oh, no. Oh, okay. You're not the twin. Never mind. Sorry, guys. And then I have Dana and Daniel. So just look closely at your gradebook grades. Make sure they match what I hand back. That's the lesson in all this. Okay. So, lots of people try to do all sorts of things with this. But the reality of this is it is a simple trinomial. And you say the sum is 2 and the product is 1. That's what we're doing here. But instead of having x right here, what do I have to have? X squared. That's how you factor it. You've got your x squared. Then, what two numbers multiply together to give me 2 and added together give me 1? No, let me say that again. What two numbers multiply together to give me 1 and added together give me 2? 1 and 1. Okay. Now, we can't factor those anymore. It's not difference of perfect square. We've already talked about that it doesn't factor to x plus 1 times x plus 1. So now we have to set these equal to 0 and see what we end up with. So I've got 0 equals x squared plus 1. Actually, I don't like how I wrote that. Let's write x squared plus 1 equals 0, and x squared plus 1 equals 0. So then I end up with x squared equals negative 1. Okay? When I take the square root of both sides of that, what do I have to do? Plus or minus. Don't forget that plus or minus. And we know that the square root of negative 1 is I. So I end up with plus or minus I. And I end up with that twice. Okay, so let's talk about what this means. Let's talk about what this means. What is the multiplicity of positive I? Yes. Okay, it occurs twice. What's the multiplicity of negative I? 2. Where does this cross the y-axis? Where does this cross the y-axis? Not 2, not 4. Plug in 0 for x. 1. It crosses the y-axis at 1. Where does it cross the x-axis? Sam? It doesn't. It does not cross the x-axis. Now, I am not asking you any of those questions, but it's good to visualize what's happening here. So, if this were my coordinate system, okay, this is going to be 1. That point right there is 1. My graph is going to cross the x-axis. So it could look something, well, let's try this, okay? So it could look something like that. That's what it could look like. It could also, I mean, we just don't know. It could also look something like this. I mean, as long as it crosses the x-axis at 1, we don't have any more information on what it looks like. Okay, we do know that it goes in the same direction and it's going up because of our leading coefficient. Okay, but we do not cross the x-axis at all. Okay, how are we? Oh, we're great on time. Okay, I've got 2 more that I want you to do, I think. Yeah, I do. Okay, I'm going to give you probably a little bit more than 5 minutes to work on these. Because both of these don't work out nicely. They are two separate problems, yes. They are two separate problems. Okay, and you may not finish them, but you're solving. That's what you're doing with these, is solving them. Okay, I'm going to go ahead and get started talking because I want to be sure that I get through both of these before class is over. The first one's a little bit dangerous. It looks super simple, and it looks like you should be able to factor it, okay? And that's the dangerous part of it, okay? Students want to be able to say that the product is 8, and so I should be able to use 2 times 4, okay? And 2 times 4 does give you positive 8, as does negative 2 and negative 4, if I multiply those together. The problem is, when I add 2 and 4 together, I get 6, and when I add negative 2 and negative 4 together, I get negative 6, okay? In order to get negative 2, I have to have negative 4 and positive 2. But negative 4 times positive 2 does not give me positive 8. Okay? I'm guessing you made that mistake. So that's a little bit why this particular problem is a little bit icky. Because you really think you should be able to factor this, and then you can't. I love it. But you know what? It's better to make the mistake today than on Thursday. It's better to make the mistake today. Okay, so we have to do either completing the square or the quadratic formula. Now, I'm going to do completing the square on this because it makes a nice, pretty completing the square. Okay? And on the next one, I'll do quadratic formula. You would get the same answer regardless of what you picked. You would get the same answer. So I'm going to rewrite this as x squared minus 2x plus 8 equals 0. My first step, now we're not finding the vertex. We are solving this using completing the square. So my first step here is to move that 8 over. So I have x squared minus 2x equals negative 8. Okay? Now I'm going to complete the square. What is half of negative 2? Good. Negative 1. Half of negative 2 is negative 1. And what is negative 1 squared? Negative 1 squared. Positive 1. Yeah, I'm scaring you now. You're like, no, it can be that simple. It really is. At this point, it is more straightforward. Okay? So now I can factor x squared minus 2x plus 1 by design. That's how we want it to be. So I have x minus 1 squared. Then I have negative 7. I'm going to take the square root of both sides, and when I take the square root of the negative 7, what do I have to put in front of it? Good. Excellent. Plus or minus. Now, what is inside that square root that I can pull out? A negative or an I, okay? And so when I pull out the negative, it becomes I. So I have plus or minus I on the square root of 7. Okay, plus or minus I on the square root of 7. Then my last step is to pull the 1 over. So that is your answer. 1 plus or minus I on the square root of 7. And in keeping with WebAssign, I don't expect you to do this, but you certainly can. Yes, sir.
I did the quadratic.
Okay.
That answer, but I have the root 7 over 2.
Okay. Tell me what you got kind of before you started simplifying. Like after you added whatever was inside the square root. Tell me what you got.
2 plus or minus the square root of negative 28. And I simplified that to the square root of negative 4.
But did you have 2 plus or minus the square root of negative 28 over 2?
Yes.
You did. Okay, good. So let's go from here, okay? So this is when you kind of did the first set of simplifying the quadratic, Okay, and my guess is that most of you probably did the quadratic, so this is a good thing to talk about. Okay, so I'm going to simplify the negative 28. Okay, so I'm going to have negative 1, which we're going to pull out, and we're going to make that I. Then I'm going to have 4, and then I'm going to have times 7. Okay, so negative 1 times 4 times 7 gives me negative 28. Does everybody agree with me? Okay, and then all of that is still over 2. What is the square root of negative 1? I. What is the square root of 4? 2. So I have 2i on the square root of 7. Is that where, did you get to this point, Alex?
Yes.
Okay. So this can be rewritten as 2 over 2 plus or minus 2i on the square root of 7 over 2. Okay? The 2 and the I and the square root of 7 are all being multiplied, so they're one term. Okay? Then, when you simplify, you end up with this. I gotcha. And so you probably were thinking about it as 2 plus I on the square root of 7. Or an extra 2.
I was thinking I had the 2 as a term, I had 2 lines as a term, and I had 2 sevens.
Yeah. No, that makes sense. That makes sense. I got it. So the root 7 is being multiplied by the 2 and the I, so you don't have to think about it as a separate term. That was a great question. Thank you for bringing that up. Any other questions on how this quadratic was done here? Okay. I want to erase all of this. Is that okay? So I can do the other one? Okay. Ignore that just got erased. I'll make it to where you can't see it. I had to cover something up so I could make these slides, so there we go. And I forgot when I erase, that happens. Okay, so what we're going to do here, what we're going to do first is we are going to see if we can factor this on the right. X to the third plus 6x squared plus 9x plus 2. You're always going to look at it and say, oh, can I factor that? Factoring is good. Okay, can it be factored? No, of course not, right? Okay, so there are only 4 numbers that you should test for synthetic division. What are the 4 numbers that could possibly be one of the solutions? Excellent. Plus or minus 1 and plus or minus 2. Tell me how you got that. Good. It's the factors of the 2. Okay, so you don't need to test 3 or 4 or 5 or anything like that. You only need to test plus or minus 1 and plus or minus 2. Now, for the sake of time, I'm going to go ahead and tell you that 2 is what works. Okay? No, actually negative 2. I'm sorry, not 2. Negative 2. So I'm going to start here with negative 2. And then I've got 1, 6, 9, and 2. 1, 6, 9, and 2. Okay? So I'm going to bring the 1 straight down. Negative 2 times 1 is negative 2. 6 and negative 2 is 4. Negative 2 times 8 is negative 8. Negative 2 times 1 is negative 2. So we do not have a remainder. Now, what happens is students forget that this is your first solution that you found. I'm sorry? X plus 2 would be your first factor. But you're correct. Those do relate to each other. So this right here is a solution, and we forget to write that down a lot. And that would happen on WebAssign. People would send me a question and say, Alicia, I know this is the right answer. And you're right. It is to the quadratic portion. But you forgot that first one. Okay? So now, this 1 is 1x squared plus 4x plus 1. This is slightly easier to identify that it can't be factored. This one's not as tricky to identify, okay? Because there's no numbers that you can multiply together to get 1 and add together to get 4. So that's somewhat beneficial. So here, I have to do the quadratic formula, and I want you guys to see me do it. So I've got negative b plus or minus the square root of b squared minus 4ac over 2a. That will be given to you on Thursday, okay? That will be given to you on Thursday. So my a value is positive 1. My b value is positive 4, and my c value is positive 1. So I have negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1. And all of that is over 2 times 1. Okay? So now I have negative 4 plus or minus the square root of 4 squared, which is 16. Negative 4 times 1 is minus 4. Okay? And I'm going to kind of go right here. So now I have negative 4 plus or minus the square root of 12. Okay? 12 has a perfect square factor. What's the perfect square factor? 4. So that's 4 times 3. So I have negative 4 plus or minus 2 on the square root of 3 over 2. Okay? Now I'm going to split that. So I've got negative 4 over 2 plus or minus 2 on the square root of 3 over 2. So my answer then is negative 2, because this cancels and this cancels. Now, negative 2 plus or minus the square root of 3, that's only 2 of my solutions. What's my other solution? Okay, x plus 2 is a factor, so what's the solution associated with that factor? Good. So I have negative 2 plus square root of 3, negative 2 minus square root of 3, and then I've got negative 2. Okay. How many times does this graph cross the x-axis? 3 times. Those are all real. Even though 2 of them are irrational, they're still real. Okay, so I cross the x-axis 3 times. Okay, I have 1 rational, which means it can be illustrated as a fraction, and 2 irrational. Okay, now,